Okay, so remember I said not 2 slides, but a few slides back that we can convert some decimals into rational numbers. And what are these decimals? Well, these decimals include finite decimals. So finite decimals just mean that they stop. So for example, pi 3.14 something 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 does not stop. It is an infinite decimal. Whereas finite decimal, for example 0.5876, it stops at 6. Those decimals are actually rational numbers, and we can write them in the form m over n. Remember, anything is a rational number if it can be written in the form m over n. And the way that we basically convert a finite decimal into the form m over n is we are essentially trying to eradicate this decimal. So we need to multiply it by a factor of 10, or sorry, not a factor, a multiple of 10 that removes the decimal. So we need to move the decimal 1, 2, 3, 4 places to make it come over here. So we will multiply by 10 to the power of 4. And whatever we multiply the numerator by, we need to multiply the denominator by that same amount. So therefore you'll end up with this, and then that will equal to 5876 over 10,000. And basically simplifying it, you'll get 1469 over 2,500. That is in the form m over n. So that is basically the easiest method to convert anything into the form m over n, if it is a finite decimal. But what if it is not a finite decimal? What if it's a recurring decimal? So when we're converting something that's a recurring decimal into the form m over n, or the rational number form, we can actually do it. The process is a little bit more complicated though. So basically what we do is, let's just say it's 3 numbers in the decimal place that repeat themselves. So for example, it's 538, then it goes 538, 538, 538. If it's 3 numbers, what we do is we multiply by 10 to the power of 3. If it was 2 numbers, then we'll multiply by 10 to the power of 2. If it was 4 numbers, we'll multiply by 10 to the power of 4. So basically what we want to do is, again, move the decimal place that many places. But this time, instead of getting 0, 0, 0, so for example, if we multiply by 10 to the power of 4, we'll just get 5876.000, right? Here we won't get 0, 0, 0 because it's a recurring decimal, so we'll get 538.538. So after doing that, basically what we need to do is we need to subtract the initial recurring decimal to obtain an integer. So 0.538 times by 10 to the power of 3 minus 0.538 recurring will give us 538. So what do we know now? Well, we know that 0.538 times by 10 to the power of 3 will give us a whole number and a recurring decimal, or an integer, which is 538 if we subtract the recurring decimal. So then what we need to do is we need to divide the integer by 10 to the power of n. So n is whatever you have multiplied to get an integer, essentially, minus 1. And once we do that, we will get the fraction form, because essentially, if you think about it, 0.538 recurring times by this will give us 538. So basically, if we want to write 0.538 recurring as a decimal, we just divide by 10 to the power of 3 minus 1, like this, and that's how we will get it in in the form m over n, or in a rational form. So I hope that makes sense. It's a little bit complicated, but once you understand it, it just makes sense. So basically, we have the recurring decimal, 0.538, and the 538 is repeating indefinitely. How can we change this into an integer? Well, we can multiply by 10 to the power of 3 to get 538.538, 538, 538, 538, so on and so forth. And then to get an integer, all we need to do is we need to multiply by 10 to the power of 3 and then subtract the recurring decimal to give us 538. And then we basically write it in this form. So we know that 0.538 recurring multiplied by 10 to the power of 3 minus itself will give us 538. So to write this in an integer form, sorry, not an integer, in a rational form, we just divide 10 to the power of 3 minus 1, or 10 to the power of n minus 1. If there were 4 recurring decimals, then we would have to multiply by 10 to the power of 4. If there was 2, then multiply by 10 to the power of 2.